So more and more people are feeding three-phase drives with a single-phase input because they don't have three-phase available to get three phases output. So what do the harmonics look like if I feed a single-phase input on a three-phase drive? So if I take a single-phase input on a three-phase drive, the harmonics do look different. And I'm going to draw that up and show you what the differences are. And you can see pretty clearly where you're going to see the difference. So if I have a three-phase power system, and again, if I feed a three-phase input to my drive here, A, B, and C to feed my motor, so we have three-phase input to the drive and get a three-phase motor. My harmonics look like that traditional double hump current. And for example, this would be a 6-pulse drive, so I'd have NP plus or minus 1 harmonics, which would be, 5 and 7, 11 and 13, and so forth. Okay, so that's my traditional harmonic waveform for three-phase input. Okay, now if I take that same drive, but I feed it, let's say, line to neutral here, and if my drive can take that voltage as an input, let's say 120 volts, I can still run a three-phase motor, believe it or not, because what are we doing with the drive? We're converting from AC to DC and DC back to AC. So I can put single phase in with my rectifier, get three-phase out. But the difference is my harmonic current looks a lot different. It looks like this. And that spectrum looks different. So our standard spectrum over here looks like fundamental, 5th, 7th, 11th, 13th. And on this one, we'd have fundamental, but we have 3rd, 5th, 7th, 9th, 11th, 13th. So in that case, I have thirds and ninths, which are different. And if I got rid of those, I would have the same as I have here. But the single-phase input on a three-phase drive yields that third harmonic. So the other issue we have to think about is, what's my neutral current going to look like, especially if I put 3 of those on the system. If I have that drive connected line to line, we have another video where we talk about connecting a drive line to line. That wave shape will still be the same, except that current won't accumulate on the neutral. I'll still have that very high peaky third harmonic current. And by the way, just like NP plus or minus 1 here, this is still NP plus or minus 1, but the number of pulses is 2 pulses. So we have fundamental, then 3rd, 5th, 7th, etc. So all of my odd harmonics. So if you feed a single-phase input on a three-phase drive, you're going to get a lot of third harmonics and ninth harmonics. So the triplen harmonics, typically, if you feed it line to neutral. Third harmonics that don't go to the neutral on the line-to-line version of that. But the wave shape absolutely looks different when you feed a three-phase drive with a single-phase input.